Hello students, last lecture we have seen proof of Leibniz theorem. Now in this lecture we see examples on Leibniz theorem. So let us see first example. If y is equal to sine inverse x, then prove that 1 minus x square into yn plus 2 minus 2n plus 1 into x yn plus 1 minus n square yn is equal to 0. So remember that if in the statement or in the equation, if there is n plus 2th derivative of y, then we have to differentiate y two times. When we get y2, then nth derivative of y2 will be yn plus 2. So here we have to differentiate y two times. So let us see. Here y is equal to sine inverse x. So differentiating this y with respect to x, we get derivative of y is y1 and derivative of sine inverse x is 1 upon root 1 minus x square. So multiplying by root 1 minus x square, we get root 1 minus x square into y1 is equal to 1. Now again differentiating this with respect to x, we get, here we use product formula for derivative. So root 1 minus x square into derivative of y1 is y2 plus y1 into derivative of root 1 minus x square is 1 upon 2 root 1 minus x square into derivative of 1 minus x square is minus 2x is equal to derivative of 1 is 0. Therefore this is root 1 minus x square into y2, and here 2 on numerator and denominator get cancelled, and here is minus sign. So this is minus x y1 divided by root 1 minus x square. This is equal to 0. Again here multiplying by root 1 minus x square. Root 1 minus x square into root 1 minus x square into y2 minus, here root 1 minus x square get cancelled, therefore minus x y1 is equal to 0. Therefore root 1 minus x square into root 1 minus x square means 1 minus x square into y2 minus x y1 is equal to 0. So this is we got when we differentiate y two times. Now we want yn plus 2, yn plus 1. So we have to take nth derivative of this equation, and for that we use Leibniz theorem. So since here is product of two terms, we use Leibniz theorem. So in Leibniz theorem, if y is equal to u into v, then we have formula for nth derivative as nc0 into un v. So here we have to select u and v. So you select u, that function for which we can calculate nth derivative, and you select v for that function who has limited derivatives. Thus, here for this product 1 minus x square into y2, we take u is equal to y2 and v is equal to 1 minus x square. And for this product x into y1, we take u is equal to y1 and v is equal to x. So, for the first product, by using Leibniz theorem, we can write nth derivative as nc0 into unv, means nth derivative of u. So u is here y2. So nth derivative of y2 is yn plus 2. So nc0 into yn plus 2 into bracket this v 1 minus x square plus next term is nc1 and n minus 1th derivative of u. So here you only minus 1 from this order, whatever order is written here. So this is yn plus 2. So derivative decreased by 1. Then this becomes yn plus 1. And v1, here v is written. So derivative of v is v1. So one derivative of 1 minus x square is minus 2x. So here is minus 2x. So each time you write one derivative minimized by 1 for u and take next derivative of v. That means take next derivative which is written in previous term, take its derivative. So here next term will be nc2 yn and derivative of minus 2x is minus 2. Now if we write next term, then derivative of this minus 2 will be 0. Therefore we terminate this expansion here. Now minus nth derivative of this x into y1. So minus into bracket. First term is nc0 un. Here u is y1. So nth derivative of y1 is yn plus 1 into v. V is x. So into x. So this is nc0 yn plus 1 into x plus next term will be nc1 and one derivative of this y decreased by 1. So yn and derivative of this x is 1. So in this way the next term will be 0 since derivative of 1 is 0. So we terminate here. Now we have to simplify this. Here we substitute nc0 is equal to 1, nc1 is equal to n, nc2 is equal to n into n minus 1 upon factorial 2. So this becomes yn plus 2 into 1 minus x square plus n and this minus 2x. Therefore minus 2nx into yn plus 1 plus here n into n minus 1 upon factorial 2 and here is minus 2. Therefore this minus 2 into n minus 1 upon factorial 2 into this yn. Next minus here again nc0 is equal to 1. So x into yn plus 1 here minus nc1, value of nc1 is n. Therefore this is n into yn. So outside the bracket sign is minus. So we have written here minus two terms. So if we simplify this, then here we see 2 get cancelled here, and we write this 1 minus x square into yn plus 2 minus 2nx yn plus 1 minus the next term of yn plus 1 we have written here, this term, so that we can take yn plus 1 common, and here also the term minus nyn is written here after this yn term, so that we can take yn as a common. So this is 1 minus x square into yn plus 2 minus, from these two we can take common x and yn plus 1, therefore, and minus sign is also common, therefore taking minus x yn plus 1 common, here remains 2n and here remains only plus 1. So 2n plus 1 into x yn plus 1 minus, here taking yn n into yn common, minus sign common, bracket remains into bracket n plus 1. Thus we got that 1 minus x square into yn plus 2 minus 2n plus 1 x into yn plus 1 minus n square yn is equal to 0. Similarly, let us see second example. Y is equal to x cube cos x. Here we take u is equal to cos x and v is equal to x cube. So derivative of cos x, nth derivative of cos x is cos x plus n pi by 2. N minus 1th derivative will be cos x plus n minus 1 into pi by 2. N minus 2th derivative is equal to cos x plus n minus 2 into pi by 2. And derivative of v is equal to x cube, therefore first derivative will be 3x square, second derivative will be 6x, third derivative will be 6. So we write here formula for Leibniz theorem, and if we substitute all the values of nth derivative of cos x and all derivatives of x cube, then we get yn is equal to x cube cos x plus n pi by 2 plus 3n x square cos x plus n minus 1 pi by 2 plus 3n into n minus 1 x into cos x plus n minus 2 pi by 2 plus n into n minus 1 into n minus 2 into cos x plus n minus 3 on 2 into pi.